Ginneken, and this is Caspár from Tergouw. We both work for a Dutch energy network company called Alliander. Alliander is a company with about 7,000 employees, and we maintain the electricity and gas network in the Netherlands. Simple explanation. So what we've been doing for the past 2 years, we've been developing a mobile app using UI5. And this app is for the maintenance engineers in the field to service the, no, not actually to service, but to cover faults. So there's something urgent in the network, someone calls and I don't have electricity. The maintenance engineer goes to the house and fixes it, and he uses our app to help him get there, and well, to fill in like a form for some administrative process. So we want to tell you. So this is to give you a little picture of what it is. So you see some people working in a ditch and fixing stuff, and here is our app in action. It's on a tablet, and he is filling in what, well, whatever, something administrative. All right, so we won't cover the app today. We want to discuss what we put on underneath as a state management library. So actually, soon I will hand it to Caspár to explain the concept of reactive programming a little bit, and also MobX, what it is. But I actually wondered who is familiar with MobX. So anyone tried MobX? Because there was last year, there was a talk about it. Yeah, you a little bit. You see familiar faces. Okay, that's good to know. So we need to explain the concept of MobX a little bit. Did I forget anything? Can I hand it to you?
I think you didn't. Yeah.
All right.
Very good. Okay, so basically I'm going to start with a brief introduction of the reactive programming. I think you all pretty much know what it is, I hope a little bit. Maybe just reactive programming. This image, by the way, is from the MobX website. So MobX is also a reactive library where you can make UI5 kind of reactive. UI5, first to explain reactive programming, there are basically 4 steps in it. Normally UI5, I would define UI5 being really good in the first part. So you get events from, for example, if you press a button somewhere, an event is triggered and you define an action in your controller, and that action modifies the state of your application. We all know that from UI5, of course, very familiar. And the reactive programming side is this part. That's by default not really into UI5, but I'm going to get to that in a little bit. So the reactive part is when your state is modified, you should get updates and you can calculate computed values. What those are, I'm going to show in a minute. You can trigger some other reactions as well based on your computed values or your state changes. And those events can route back to actions again. So that's basically the kind of a brief overview of the reactive programming model, I think. And also an interesting or very important part of MobX, this line is also from the MobX side, anything that can be derived from the application state should be derived. So that means that the base of your application, kind of like your master data, should not be modified. And if you get data that's based on your master data, you should not modify your master data or do complex calculations and put that in your state back again, but you should just use the computed values. That's what I would say. So that's a brief introduction to reactive programming and also a little bit into MobX. I'm going to start with what we will not discuss, because there are also some other libraries, of course, which can kind of do the same thing. Reactive programming in SAP UI5 with the managed object model. I found that it was only in kind of a beta phase, but I'm not too sure what it is right now. You also have Redux, of course, and you got the basic JavaScript accessors like the getters and setters, and you can do some stuff with that as well. But we are not going to discuss that. Maybe a little bit at the end, but I'm not sure. And there has also been an earlier talk about MobX during UI5con last year, so there's going to be some repetition with that presentation. So I hope you're okay with that. First off, I'm going to show you a demo about how UI5 manages, for example, computed values right now. So we built a few applications, and those applications we are going to show you in some demos to prove basically the working of MobX and show you it as well. Let's see. So first off, we made 4 demos, and the first demo is to show you what you would normally do in your UI5 application using a JSON model. Of course, you can also use an OData model, but I choose the JSON model for my demo. We built the application with a few basic functions in it. The application is basically just a list of books, and it's a really simple demo. But a list of books, and you can add books, add or remove sold books. You get a list of the bestsellers, and it's a simple application. But there are a few key functions in this. That's the add sold book, the remove sold book, the show book change, show books sold record, and the calculate totals. And the calculate totals is the kind of the key feature in this demo, because if I would, for example, add a sold book, so I got the application running right here.
Show the application.
This is the application. It's gonna, all the 4 applications are gonna look similar, but they're gonna have some different stuff underneath the hood. So you can just add some books, for example. A message toast is being triggered underneath. It's a really simple. Simple application, and if I get more than 15 books, then the book gets pushed into the bestseller array. And we also have a total sold amount over here, which shows the total sold books. Right now, if I'm adding a book in your normal JSON model example, then you would, if you want to calculate the totals, for example, then we would ourselves, we have to call the function calculate totals in order to derive, kind of encode the totals. If I look at this function, we get all the books from the model that we built. For each book we are calculating the totals, and eventually we push that into our model in the total number sold books. And also the bestseller array is also defined over here, so it's all being calculated in code. And I have to, as a programmer, I have to be in charge, and I have to implement the code in order for it to work. So this is not reactive. It's, or as I would say, it's not the reactive way that we want it to be. So that's where we are implementing MobX. And I'm gonna firstly explain you some, basically some key features of MobX. So first off, we get the MobX observable. MobX works with observables, and observables are, the MobX code, as the term observable, I think, explains it, observes the properties of the object, and based on that observing, it fires the triggers, the reactions, that kind of stuff. So how would you define an observable? Like this, MobX observable, and you just put in your normal data as you are used to. And I also put some one getter in this example as well. If you're familiar with JavaScript getters and setters, it looks identical. It basically does an identical thing. Only the observable on the top line makes sure that the getter also is observed. So for example, you can see if I execute the code on the bottom, I can also directly add a sold amount or an integer to the sold amount in order to trigger the getter of the bestseller and trigger the function that's inside of it. So that's the observable. You got some other key features that you can put on those observables. That is the MobX auto run. The auto run is triggered once immediately, and afterwards, every time one of its dependencies change. So if all the code that I got in my auto run, MobX observes those properties all the time. So this gets triggered if this code is run, then the first time it's triggered. So the console would log a statement. And afterwards, every time the bestseller, or in this case also because I use the book name in the console log, if the book name changes, then the auto run gets triggered again. But you will see that in a minute, how it works. You got the MobX when function, that's a really important one. It triggers when the function above returns true, and then it removes itself. So it's basically just a single time trigger. In this case, I observed the amount sold. If it is bigger than 10, then one time only the console logs the statement. And lastly, I wanted to show you the reaction. The reaction is triggered when the only when the observed property changes. So in the first case, the auto run, everything that I put inside the auto run statement triggers the function. And in this case, only the book.bestseller triggers the function. So I hope that's all a little bit clear. Then I'm going to show you another demo of the second application. So the first time we had the calculate totals, which is we had to trigger the calculate totals in order to fetch our total amounts. And in the case of MobX, first off, over in the component, we are creating a new model. It's a MobX-model, so it's as you are used to with a JSON-model, looks really familiar, I think, to you. And you put in a new observable into that MobX-model, and we got some mock data to work with. Also, one small thing in the mock data, I built in the two getters. So these are not basically MobX. This is not MobX stuff. This is JavaScript stuff. But MobX is able to observe those getters as well. So if the value of the getter changes, then you can react to it with MobX. So in this case, if I press the sold book button again, then I don't have to calculate totals. I don't have to do anything in order to make my application work. So this is the second demo. If I press the button, then I don't have to update data. I don't have to react to I don't have to calculate stuff. Or as you can see, the total amount is just going up, and the bestseller array is being filled, without me having to do anything. And that is due to, like I said, the MobX model, and it reacts to your data. So also, if this getter changes, then it just pushes all the stuff directly into your UI again. Let's see if I forgot anything.
I think you should show the auto-runs component.
Oh, yes, of course. In my, let's see, in the component, I got these, when I set my model, I also set the MobX functions. So that's basically just a function that I built. I fetch my observable, and I make a MobX auto run, a MobX when, and a MobX reaction. So those are the examples that I just shown. In the case of the auto run, if the books array, the length of the books array changes, so for example, if a book gets added, then there's a message toast that's being shown. That's the auto run, so it triggers once, and afterwards it still keeps on watching the length of the array. And so If I push a new object into my array, that's also being observed, and I can just use the length in my auto-run. That's really handy. Let's see, the MobX when triggers when the total number of sold books gets over 500. And there's also a reaction on the bestsellers array. So this gets triggered once, I think. No, this one gets triggered once, sorry. There's one last thing I wanted to show you, and that's also a bridge to my colleague Leon again. And that is the structured part of MobX, because this is all just the basic MobX. This has nothing to do with state tree yet. And the thing that can happen right now, and also in UI5 if you're not careful, if I add a new book, for example this one, I don't know if her name is written like that, but I hope it is. For example, I add 500 books. You have to watch in the background the total amount sold. If I add this book, then the total amount sold suddenly is 61,500. So something is going wrong here, and my colleague is going to explain what it is.
Let's explain it. All right. So thank you, Caspár. Let's get back to the slides. All right. So we've been experimenting with MobX for the past 2 years, and we found it's useful because of these auto-run functions. You can just define when something should happen, right? So the auto-run function, for example, which you saw, that's all the code you need. Once you have an observable, you just need to say, do this. And whenever anything changes, it just does it. So it's like magic. It can feel really nice to work with this. It's like, hey, it just works like that. So it's a really nice developer experience. But what happens is when you start experimenting with MobX, it's a very flexible library. So you can just inject it anywhere. You can make observables anywhere. So you can imagine, I tried to show you a little bit the app we built. It's quite complex. We've been building it for 2 years with a development team of 5 developers, I think. So the code base, it's grown a little bit, and at some point it gets hard. You get certain, you get bugs, you get errors, and you're like, why does this happen? Why is this all of a sudden a problem? You go into the code base and you get, this. I mean, if you programmed a lot, you know this. You just get confused. So what I was searching for a way to, bring some structure to it. So you Google a lot, and you find this library called MobX State Tree. It's also made by the author of MobX itself. And he says, okay, this is an opinionated way to use MobX. So MobX is really free. If you want to have a structured way to do it, use this. So let me point out some features that MobX State Tree has. Strict data types. Anyone who is coming from a different background, different than JavaScript, knows that a lot of programming languages, they have strict data types. So when something is a string, it should always be a string. It's not possible as we did, like, hey, we saw a number and all of a sudden it just added a string to it, so it became a string. That's not possible when you have strict data types. So that's a feature that is in MobX State Tree. It's really useful because as a programmer, this thing I'm looking at, it will always be an integer, whatever happens in our code base. Protected data is also really interesting. So those observables, you move those variables around in your application, and you're free to edit those observables anywhere, right? So you have this name property on a book, and anywhere in your code, you can change this name property, and it will be changed. So what if what if I want to see where it all gets changed? I do a search. I search the name property, but it pops up in 100 places because it's the read actions are programmed like this, and the write actions, they are also done on the same object. So I'll get to it how MobX State Tree solves that. Some structure, how should I put this in my application? So we think we figured out ourselves a way to put this nicely into UI5. And also a really nice feature of MobX State Tree is that you can easily pack up your data in a JSON format and move it somewhere, move it to the local storage or move it to a server, and have a new app somewhere else which has the same MobX State Tree in it, and instantiate this this model with the JSON format, and boom, your app is live with all the getters and everything that you built. So you can build a really complex tree of models, and it's really easy to pack it up put it somewhere else, and instantiate it again. So let me introduce you to some key concepts in MobX State Tree. So the most basic thing you do is you create a model. So no more MobX observable and here's an object, but you say, okay, we will create a model. So we will define what is a book. What is a book for us? Okay, a book has 4 properties. It has a name, it has a date released property, it has amount sold property, and it has a summary. What can we tell about the name function? So the name property, okay, this must be a string, right? Date released, it's a date, it's a JavaScript date. It will always be a date. No more problems with, I put this string in there and it's not a date object anymore. It will always be a date object. Amount sold is an integer, so not a float, not a number, it's an integer, so only natural numbers. And summary, it's optional. You can add it, but it's not needed. You know, it's types dot maybe. You say you can have it, but it doesn't matter if you don't. But the other properties, they're required. So there's no way to make a book without these properties. So let's create a basic book. So let's create a book, Moby Dick. It's released now. I think it's from the 19th century, but anyway. Amount sold 0, and to show you, book.name shows you a book. So to prove the protected nature of the data, let's try to change the number of the amount sold. So it's 0 at the beginning, and I try to add it with 1. But what happens? It throws an error. So MobX State Tree said, I cannot modify book. The object is protected. It can only be modified by using an action. So it's safe. There's no way to change the amount sold property. How should you change a property? You define an action. So if I want to add a sold book, I say I create action with this syntax. It's modern ES6 syntax. So it makes it quite readable, or else you would have all these function declarations everywhere. Add sold book, it just adds the sold book on the self object. So I'll show you later that it still works. And the derived values. How can you? So this is like the data. This is like the master data. This is you want to be careful with this, but you're free to make as many views on your data as you want. So if you need, you're making your application. I feel like it would be really useful if I have this property on the book that says to me if it's a bestseller or not. I want a boolean. I want a true or false. Maybe I make something visible or invisible in my UI5 app. So I just create a bestseller property, and I define, like some business logic, I define when is a book a bestseller? You know, what is my definition of a bestseller? It's here. It's right in the model. So you can just, it's a way of communicating as well. I can tell Caspár, hey, look at the book model. What is a book? When is a book a bestseller? It's a bestseller when it's sold over 10 times. And then last, and then I think I'll go to the demo, is the concept of serialization, and it's actually called snapshots in MobX State Tree. It's really easy to back up your data, as I said. So what if I have a really complex tree? This is of course a very simple example, but I want to get my JSON format from it. You just say get snapshot book, and boom, you have your JSON format of your library. And all the views, they're not in there, so it's only the master data. And you can also have a trigger, like every time anything changes in the app, I want another snapshot. So if I do this, it will console log every time my data changes. And imagine what you can do with this. Imagine if you have 2 applications connected by WebSockets, for example, you just say, hey, whenever something changes in the first app, update the second app by WebSockets. And you have a UI that is in sync. That's actually the first example on the MobX State Tree website. They show that, visualize that you can just have 2 UIs in sync. It's really nice. So another way around, it's really nice if you have this tree of objects, and you have something changes on the server, and the server just said, bam, here is the whole state. This is your whole new state of the app. Normally, you can imagine it's quite difficult. Okay, what has actually changed, and how should we update UI? With MobX State Tree, it's really easy. You just say apply snapshot. And the cool thing here is, it just applies the stuff that's changed. So if I have this really complex array of objects, all these properties, and only my name of a book somewhere in the tree has changed, it will only change this object, and the rest will be kept as is. So all your triggers, everything they will not fire. It will only fire the trigger on the name. So that's a really nice feature. We use this to update we have a list of all the work orders for the field engineer, and we just update everything all the time. We get all the data in. It's a huge JSON object, and we just say apply snapshot, apply snapshot. So the objects are kept alive. And also you can instantiate new object from a snapshot. You can say book.create snapshot, and you have a living tree. So you notice I'm quite enthusiastic about it. Actually, I can't imagine how we would have done this without this this nice library. So let me show you a little bit the same example, but now using MobX State Tree. And after this, I'll show a cool example of how you can even build further upon it, and you can maybe build things that, you know, beforehand you could not really imagine how you could make them. So now the same example. Let's go to demo 3. We have this book model. So earlier I showed you just the UI5, just the MobX State Tree code, but of course we need to plug it into UI5. So that's where the UI5 module syntax comes in nicely. You just wrap your book model around in a UI5 module, and you have your book model available as a UI5 module. So I just create a module, and I return types.modelBook with the views and the action, plus, minus, add salt book, remove salt book. If I can pack it up, I mean I can use it anywhere I want. Also, I have this bookstore, which is something we found out by using it. It's quite nice if you have a UI5 module, which is a store, and the store contains your data. So in this store, you have this array of books. There's not enough time to show all the features, but you can imagine there's types.array. This is also a definition of, okay, there's an array here of all the books. So just say books should be an array of book models. And also here we have our few bestsellers. I mean, you can read the code. I hope you can just see what it is just from looking at the code. Total number of sold books. This is the definition, or this is how it is calculated. And let me iterate that it's only updated when the values used in the function is changed. So you can just it removes some sorrows. We have the add book function here to add a book. There's actually an important thing we discovered is that in UI5 we're not really, well, at least we still don't use like the node way of developing, which maybe now you can do, but we had to use the standalone build of MobX State Tree, and it's a production build. So for optimization, they don't really check the strict data typing, as I said before. So you always need to say MobX State Tree.typeCheck to check that the incoming data is actually validated against your model. But that's a minor thing. You just need to think about. Okay, I use a prediction build, and let's add it here. All right, maybe because of the time also a little bit. Let me just show you that you can use this bookstore. As I said, it's now wrapped in the module, and I use it here in my controller. So I say on add salt book. I just pass it through to my MobX bookstore. So I just say add salt book. Actually to my book. So the book is binded to the view, and I just get it, which is MobX observable. And I say add salt book, so this will be this function that is run. All right, enough code. Let me show you that it still works. I mean, we haven't really changed anything functionally, but I just wanted to show how you can make the same project with different code. So it still has the triggers. You see here below, you see the message toast, right? Anytime it gets a certain threshold, there's this message toast. There's this bestseller list. All right. So I hope you can see a little bit what makes enthusiastic. Let me show you one more cool thing, which we made. Actually, I think the code is a bit too it's a bit too much to cover everything. But because of the nature of this serialization and this snapshotting, you can imagine that at any time you can get the whole state of the app. So I can just get a snapshot of, okay, this is the app with all these books and all these old books. What if I save this somewhere in an array? And every time I do a change, I save the whole I save the whole thing again in an array. I get the whole array of my history, right? So what if I can like go back and forward in my state? How cool would that be? At least I think it's cool. It's always a question, right? So let me show you the last example, which is a bit more advanced example. I just click here all the time. And you see the slider above, it changes. So what if I go back? You see? It changes everything. You just look at the history. Okay, I want to back up my data, save it to local storage, and refresh my app. I want to be back where I started. Okay, so I save everything, including the history. So it's like an extra step. And I refresh my app. And then it gets back to the initial state, but then I recover my local storage. And I'm back. It's pretty cool, right? Thank you. You know, this is the thing. Once you have this structure, you can build upon it. You can build further upon it. You have a property called bestseller. You can make a filter of all the bestsellers, and you can build upon it. So you can imagine we had to have a simple example, but maybe you can imagine you can build on this. You can build some cool stuff from it. Did I forget anything?
I think you didn't.
No? All right.
It's really good.
Let's wrap it up. Maybe you didn't catch everything, maybe it went too fast, I'm not sure, but I made an article. It also covers all these examples. So it just got published today because of the review process. So you can look it up. It's also, if you Google UI5 and MobX, I saw it's a second hit, so I'm really happy with it. And yeah, the example projects, you can, of course, it's linked on the page, but it's right here. So if you have the slides later, you can check it out. And I think it would be nice to end with some questions. Well, thank you for your attention. We have 10 minutes, I think, right?
Yeah, we have 10 minutes, so thanks, Leon. Thanks, Caspar. So if in case you guys have any questions, so we have time to ask questions now for 10 minutes, so I'll restrict the time.
The mic is here.
Thank you.
Yeah.
So you were using this MobX model?
Yeah.
Is this open source somewhere, or
It's
how you can get it?
Say this because we're actually building on earlier work. There is this really nice article that's written on MobX and UI5, and actually that became a starting point. Oh, sorry, still the presentation mode. Okay. It's by a former member. I think it had something to do with the privacy laws that came up. This really explains nicely how you can get MobX to work inside of UI5, and he made a library to do this. This is the MobX-model library. So, where is it? Somewhere. Yeah, here it is. Now it's, I think he left SAP, he worked for SAP, so now it's been taken over by someone else. But this is just, you copy the project and you put it in your own project, and you use the UI5 module syntax, and you just have a model that's like the JSON model, but then it's compatible with the MobX observables. So it's really easy to integrate it. So this is what we use.
Okay, I have one more question. you say the actions are only executed when properties changed which are contained in the action code. So how does MobX know which JavaScript variables are contained in the function?
That's a really good question. I don't really have an answer to it. There's this author of MobX called Michiel Weststraten. He's a Dutch guy. He works at Mendix actually. And they use MobX under the hood. And he can explain it very nicely. But it must have something to do that it inspects, really looks into the function, and it sees what the variables are used. I think it's something like that, but I haven't really dived into it. The thing is, if you, as a user, it just works. That's the cool thing. So it can detect what kind of variables are observables, and then it just listens for changes in observables, and then it just triggers. So that's a really interesting question. I still need to find out.
Any more questions?
How does OData work together in MobX State Tree? I mean, OData is some sort of declarative syntax, and you get this from the back end, and it kind of controls this. Did you, for this field worker app you were developing, or you are developing, this is just REST you get, or do you work with OData?
Let me explain. So we do use OData because our backend is XSA and HANA. So like, but you can also run on SAP Cloud Platform, right? So we do use OData, but because of the nature of our app, actually we're kind of a front end for a legacy system that we have. And this legacy system, because of reasons, also because because of the speed of development, we chose that this legacy system just outputted a large JSON file. So we decided that putting it nicely into a OData format would be too hard, because the data is not coming from HANA. So we already used large JSON objects from the start. So with this method, we just formally specified in the front end what the data should look like, what we can work with. So in our use case, it's covered it quite nicely. So we don't really have an opinion what's better or anything, but you see this is whole, this is really like a custom front end, like totally, right? So it's not like OData focused app. That would be another approach. But for us, it worked really nice like this. Does it explain a little bit? Yes. Yeah? Okay.
So we have still time for more questions?
One more?
You didn't show the view binding. Is there any difference,
sorry.
or I didn't?
The views work. Yeah, let's show the
yeah.
views. It's really good. Yeah.
Okay, thank you.
So let me show the third example. For example, you just have this view, and for example, we run across. It's actually, you know this already. It's just what you're used to. So I have here the total number of sold books, which is a view. So it's not a JSON. It's coming from MobX, and this is what you saw in the footer.
Mm-hmm.
And also here you have a table with items, books, but the books is coming from that bookstore.
Okay, thank you. Second question, a small one. I know it from NGRX, from Angular, that you use for each application its own model. So you show book model, or how do you do it internally? Do you use small models, or do you use application-wide models?
That's also a really good question. That's also something that's still, I think, we're still figuring it out. But I would propose that you have as small models that you can, and that you use named models, because the syntax would be really nice. I would just say, my viewer would say bookstore, books. You know exactly where it's coming from. So that's something I hope I put in my article, that you use a name model, and use a name model for every store you create. And actually the MobX documentation tells you that you should at least have a UI store and a domain store. So the UI store is for all your UI logic, and your domain store is for your domain data. I'm not sure if that's needed when you use all these views, but maybe, you need to figure out for yourself, I think, what is used. useful, but don't make one big model. I don't think that's the best approach. I think you should split it in files and have every file their own model.
Okay, thank you.
Yeah, we have another 2 minutes for.
Are there points where the UI5 framework and the MobX philosophy interfere?
When do they interfere?
Well, I don't think they interfere, but the MobX model, we did have to make an adjustment on the OpenUI5 MobX model. It was for the list binding, I believe.
Yeah. We had some minor issues. Also doing with the versioning, I think that wasn't really for MobX and mobix-state-tree, but that's of course not really a UI5 problem. I think the most important things I put in the article, it's the type check thing. It's really important. But
I don't think there were any conflicts between UI5 libraries and MobX libraries. So.
And the frame, of course, you use one-way bindings and no complex bindings. Those things you leave out because you take that all in the MobX logic.
Some logic to the MobX side.
Yeah, exactly. Yeah. And furthermore, no interference between the two frameworks. That's great. That's great.
Yeah, I would say no.
All right.
No, in general, it's really nice. We had some things, but I hoped I put it in the article that you don't have to make the mistakes we made. Or mistakes, the knowledge we didn't have yet. Yeah.
We are up with the time now.
All right. Thank you.
Thank you very much.